Hello, am I audible? Okay. Is the screen visible to you all? Okay. So in our last lecture, we had already completed 802.11, and we are now moving to the bridges, where bridges are used to convert to connect to different LANs. This one, this is the bridge. Hello. Okay, and we had also discussed about why we require bridges. Uh, in case if the lands are far apart, then it can be connected through the bridges. And as we know that for the Ethernet, the maximum distance is up to 2.5 kilometers. And if we want still greater than that, I mean, if the distance is still increased, then you can connect to two different lands using a bridge. Then splitting the load so that the collision domain would be just a minute. Right. So now, in case if there are number of systems which are in a single collision domain, then the possibility of collision would also be increased in case of a single LAN. Yeah, whereas if we split into multiple LANs, the collision, the number of hosts would be divided into different LANs, and hence the number of collisions can also be reduced. Okay. Then it can filter the garbage if in case if some system has failed and if it is continuously inputting the frames, then the bridge would stop. I mean, it would not forward those frames to the other network. Okay, and hence it can save. It can filter these garbage frames which are coming to that particular bridge. Then it filters the sensitive information, like since it is working in the promiscuous mode. That means promiscuous mode means what? All the hosts in the network can access the frames. Okay, since it is working in the promiscuous mode, and if we want that some sensitive information, it should be restricted only for a particular region or for a particular LAN, then such sensitive information cannot be forwarded to the other lands. Okay, and hence it can the sensitive information can be preserved. So this we have discussed in our last lecture, and will continue further with bridges from 802.x to 802.5. That means either it can be 802.3 to 802.4 or 2.5 or 802.11 to 802.3, etc. Okay. So how to convert, how to connect, because as we know that we are having different plans with different MAC protocols, okay, with different IEEE 802.x standards, okay. So for example, say suppose if we want to send a host A wants to send a packet from to host B, send some message to host B. In that case, from the higher layer, what it will do? At the network layer, the packet would be constructed. Then comes the LLC, that is a logical link control. What is the purpose of this? 802.2 we have discussed. So whatever be the type of MAC that is 802.x, whatever we are using at the underlying layers, okay, that should be transparent to the network layer or the higher layers. Okay. So LLC would provide some header here. LLC header would be provided, and that packet with this header would be forwarded to the MAC layer, where assume that this is a wireless type of the host is in the wireless network. Then what happens? The host, the MAC address, the MAC layer would with this packet, it would provide that header as well as header would be provided with this packet. As you know that every IEEE 802.x standards would have different frame formats, isn't it? So here it would provide its own header, then it would be provided to the physical layer. So physical layer, the purpose of the physical layer is to just transmit the frame the way it is. Okay, it would not convert or it would not modify any of the data which is provided here. Now, as it moves through the wireless LAN and through the bridge, okay, because the bridge has to, now it is a function of the bridge to convert the frame which is in one format to the other format. So when it moves to the bridge at the physical layer, it would receive it because the bridge would work at the data link layer. Okay, then it would move to the MAC sublayer, and now this 802.11, the header would be removed from this. Okay, and it would be provided to the LLC sublayer. Now this packet, since it has to move from wireless LAN to the Ethernet, so the host B is connected to the Ethernet. So now the bridge has to convert the frame format from 802.11 to 802.3. Okay, so LLC, this header of this 802.11 would be removed, and it would be provided to the logical link control, and then at the MAC sublayer at the receiving end, at the other port of this bridge, it would be converted to 802.3. It is added with the 802.3 header, and then it is provided to the physical layer, and through the physical layer it is given to the host B, which is connected to this Ethernet. Is this thing clear? This is how the bridge would convert from one format to the other format. Is it clear, everyone? Okay. Now, what are the problems for which are faced while we are converting from one format to the other format? That we'll see. So, what do you find in the frame structure of 802.11 which is not there into 802.3? Can you tell at least one of them? In the last lecture, we have discussed about the frame format of 802.11. The type field. Any other? We have come across the duration. Say suppose this is my 802.11 frame format. Here we had a duration field, isn't it? So that duration field is not present here. Okay, so it does not make any sense of this duration field into this 802.3 packet frame. Okay, that is one problem. And even this in the wired networks also, the frame format of 802.3 is different than that of 802.4 or 802.5, isn't it? That we have already learned. So the other problem is, say suppose here it is providing the in the frame control field, we have that encryption. So what happens, the 802.11, since it is a wireless type of network, it would encrypt the frame, isn't it? Whereas the 802.3 does not perform this encryption. So when the encrypted frame would be provided to 802.3 host, which is at using this 802.3, it does not know anything about this encryption. Are you getting me? It would not be able to decrypt it, and hence the message would not be interpreted correctly. Are you getting this, all of you? Okay. Then the other problem would be with the maximum frame length. Say suppose one IEEE standard is using some different maximum frame size, whereas the other one is using some the frame size which is having the smaller value. In that case, some of the frames would be lost because it cannot accept the frame which is greater than its limit. Okay. So that is also a problem with having the heterogeneous type of connection. Fine. The other type of problem which can be faced is with the uh, data rate. So, for example, if we are using a fast Ethernet or gigabit Ethernet, in that case, the data rate would be too high. Okay, so if suppose the bridge is connected here between the fast gigabit Ethernet and a simple Ethernet. So what happens? The gigabit Ethernet has having very high data rate, and it would start pouring the data to the bridge. Okay, and what the bridge would do, since it cannot forward it at the same rate, some of the frames which are buffered here at the bridge would be lost. If the buffer is full, no more frames can be placed into the buffer, and it would be lost, and it cannot be. I mean, it cannot. I mean, it cannot pass those frames to the host B, which is having a higher, lesser data rate than that of the transmitter rate. The other problem, what we had discussed, is about the encryption. So 802.11 frame would be encrypted, whereas this would not be encrypted. So since it would not be able to decrypt here. So in case if we want to send a frame from 802.11 to 802.3, then the higher layer has to take care about the encryption and decryption, and it should not be at this layer. Are you getting me? The encryption of the data should be done at the higher layer rather than it is at this layer. Okay, then the packet, while it is coming from the higher layer, it should be the encrypted packet. And then at 802.11, it need not encrypt it. But at the receiving end, while it is moving this packet to the higher layer, it is a function of the higher layer to decrypt those particular frames. Hope everyone is clear with this. And the next point is the quality of service. Okay, the 802.11, if it is in the PCF mode, that is the point coordination function mode, it provides a better quality of service because in that case, it is sure that there would not be any collision, and hence, since we are having a base station, then the quality of service would be better in provided if it is in the PCF mode. Okay, but there is no such provision in the 802.3. So these are some of the issues which are faced by the bridges while it is connecting between two different types of LANs. Okay. Hello, is this thing clear? Now our aim is that these bridges, so we have discussed this, it has different frame format. Every IEEE standard is having their own different frame format, different data rate, different maximum frame size, the security, that is the encryption, and the QoS support. So that all these points we have discussed. So next we'll see about the how the bridges are configured and or how it is used. Okay. Now, whenever we are having this, say suppose we are having 4 different lines and they are interconnected with each other with these bridges. B1 and B2 are the bridges. Our aim is that it should be the bridges should work as if it is a plug and play. As soon as it is plugged, no configuration should be done, and it has to work perfectly. That is the aim while we are connecting any bridge between different LANs. Fine. So how this bridge would know which are the host on its say suppose this is port number 1. This is port 1. This is port 2 of the bridge. This is port 1, port 2, as well as port 3 of the bridge. Okay. So now bridge B1, it should know that A and B is, it can reach A and B through the port number 1. So this is port number 2. It can reach port number C, D, E, F, G, H through port number 2. Okay, but how should it know? It should be transparent to the uh, users or to the higher layers. Okay, so it works in this way. In every bridge would maintain a table. Okay, and in this table it would make an entry that to reach to host A, it has to forward the frame to port number 1. To reach to host C, it has to forward the frame to at port 2, and so on. Hope you are getting this. Okay, so such table is maintained by all these bridges. These are the hash tables, and these are maintained by these bridges. Initially, this table would be empty. Initially, this table would be empty. There would not be any entry into this table. Then what happens? When some host A is sending a frame, so this host A is suppose these are all the Ethernets. So it is having the source address say A, it is having the destination address say suppose D. Okay, and some data it is sending. Okay. By looking at this at the frame which is sent by host A, since it does not know where the D belongs to, so it would forward those frames to all the output port except the one from where it has entered. Are you getting this? Say this is my destination. Okay, and there is no entry. Initially, this table is empty and it does not know how to reach to the destination D. Okay, so what it will do when a frame arrives at this port, say suppose A has sent a frame to D with source address A and destination address D, and since this frame is coming through this port number 1, and since B1 does not have the entry of the host D, which is into this table, it would forward that frame to the outgoing port. Okay, it would forward. So suppose here, if it is there, it would forward to all the outgoing ports except the one from where it has come in. Okay, so now, but what it will make out that it can reach to host A through the port 1. Are you getting me? So initially it is empty. Now when the source address A is sent here, so it would come to know that it is fine. It would come to know that the B1 can reach to host A through this port 1 because the source address is A and it is coming from port 1. So it would make an entry that A can be reached through port 1. Similarly, if C is sending a frame, okay, to since it is an Ethernet, it is just broadcasting. That frame would reach to the B2 also, and that frame would reach to B1 also. So what B2 would do? It would make an entry that C can be reached through port 1. Similarly, B1 can make an entry that C can reach through port 2. Are you getting this? If C is sending certain frame, then the source address would be the address of C. The destination address can be anything. Okay. By looking at the source address and by looking from where that particular frame is occurring or it is coming, based upon that, an entry is made into this hash table. Hope you are getting this. Hello. Now suppose C wants to send a frame to A. Now what it will do? It has broadcasted. Yes. So it would be entry of H. All these entries would be there. A, B, C, D, E, F, G, H. Okay. And from where it can reach. Yes, it is something like a router itself. It is here. It is performing the forwarding itself. It is forwarding the frame to the output port. Hope you are getting this. Okay. By looking at the source address, it would make an entry into this hash table. Now, say suppose G has roamed from this particular LAN to say suppose this LAN. Now G has it has uh, uh, I mean it is disconnected from this LAN and it is connected to this LAN. In that case, what happens? Uh, this hash table, it would make an with this hash table there would one more entry which is known as it which provides the timing. Okay, at what time a frame has arrived, and the timestamp would be provided here. If suppose this entry is uh, I mean if it is too old, okay, if the entry is too old, then this particular entry would be discarded from this hash table. Are you getting this? So suppose E is silent for a longer period of time. Then if E's entry is there and no, if E has not sent any of the frame uh, uh, to this through this LAN, in that case, whatever the entry of E was there, and if it is too old, then it would be removed from this hash table. And once again, whenever E would send send a frame, at that time a new entry would be made into this bridge. Are you getting this? Hello. So this is nothing but the uh, promiscuous mode. Initially, when it does not know from where it has to reach to the destination, it would forward the frame to all the output ports except from where it is coming. So that is nothing but the promiscuous mode. It is transparent. That means this bridge is the hash table. It is learning itself. It is not so manual configuration is not done in here. So that is and it is transparent to the higher layers, and it maintains a hash table. Okay, so that we have discussed, and it is backward learning. So that it is transparent. This is also known as a transparent bridge, and it is using backward learning. Backward learning means what? Based upon from where the frame is coming. So by looking at the source address, it would make an entry into the hash table. So that is nothing but the backward learning. Okay. And dynamic topology. So as I have discussed that if suppose the topology has changed, or if some of the hosts are moving from one network to the other network, then dynamically those entries would be updated into the hash table by using this timer. Okay. So when it times out, that entry would be removed from the network, and a new entry would once again when the host would send a frame, at that time a new entry would be provided into this hash table. Is this clear, everyone? Okay. Now there is one problem with this. So if I summarize this, okay, if the destination and say suppose here in this example, if host A wants to send a frame to host B, and B's entry is not there into this hash table, okay, then what it will do? If B's entry is not here into the hash table, what the B1 will do? Will it forward, or will it would forward the frame to the outgoing port? Are you getting this? Okay. So in case if that entry is here into the hash table, so B is through port 1, and when A has sent a frame whose destination is B, in that case it will check whether the B is in this port number 1. That means what happens in that case, it would not forward that particular frame further to the output port. Hope this is clear. If the source and destination is in the same LAN, then no need to forward that particular frame at the output port or the other ports. Whereas if it is at two different if the entry is there into the hash table, then it has to forward to only that particular port where the destination is present. Whereas if the destination is not known, In that case, it has to forward to all the output ports, which, for example, it has to forward to port number 2 as well as port number 3. Is this thing clear? So if destination and source are are at the same LAN, then it has to be discarded. So bridge it would discard the frame. It would not forward the frame further. If they are different, if destination and source are different, then forward the frame towards the destination. And if the destination LAN is not known, then just broadcast to the other networks. Hope this is clear, everyone. Okay, this is the summary of this. Now, what happens here? In case if there are loops, so you can see that here there are two bridges which are connected to two different LANs. Okay, and so suppose this is my host, and it is a frame F is generated. And since these are the bridges which are connected to these LAN, so bridge B1 would send a frame through, this is port 1, this is port 2, it would send it through the port 2. Okay. Meanwhile, B2 also listens this particular frame, and from port 1, it would send it to the port 2. Now, the new frame which is designated here is F1 as well as F2. Now, F2 would be coming here and F1 would be coming here. Okay. So what it will do, this would be again forwarded by here, and this would be forwarded here, and this would be continued, and you can see that the number of frames would be there into the network. Are you getting this? Number of copies would be present into the network. So what happens here? To avoid this problem, the loops should be removed. Wherever there are loops, those loops should be discarded, or it has to be removed. So for this, they are using the spanning tree. Okay, so some of the connectors or some of the bridges are removed. Removed means what? I mean, they might be present into the network as a standby. For example, if say suppose bridge B1 fails, okay, in that case B2 would come up. Are you getting this? Okay, so by using this spanning tree, we are overcoming this problem of looping. And for this, how to construct the spanning tree, that we'll see. Say suppose if I'm having, these are the LAN 1, there are 4 LANs, LAN 1, LAN 2, this is one more LAN 3, and here it is LAN 4, and these are interconnected with these bridges B1, B2, B3, B4 and B5. Okay, now for constructing the spanning tree, since we are removing some of these connections what we are using, okay, for constructing the spanning tree, one of the bridge should become the root of this tree. Okay, now how to decide which of these bridges would become the root? Are you getting this? Since we want to construct a tree, so for constructing a tree, there should be a root, isn't it? So to choose one of the bridge as a root of the tree, what it has to do is all these bridges would broadcast their own serial number. So every bridge would have certain serial number, and this serial number would be broadcasted. That means B1 would broadcast its own serial number, B2 would broadcast its own serial number, and so on. So the manufacturer, what it will do, for every bridge, it would provide a unique serial number. Every bridge would have a unique serial number, and that would be unique worldwide. Okay, one bridge serial number would not be same for the other bridges. So since all of them have broadcasted their serial numbers and everyone knows each other's serial number, the one which is having the lowest serial number would become the root. Are you getting this, all of you? Hello. So one which is having the lowest serial number, that would become the root. So in our example, if we consider that B1 is having the lowest serial number, and that would form the root. Now The other step, what it has to do, what it will consider here now, B1, these bridges you can see here, and even these lands, they became the vertex. So you can see that B1 land 1 is there. Instead of showing like this is a vertex of land 1, and you can see B1 and B2 is the land is having this B1 and B2. You can see that this B1 and B2 and so on. Now, the weights are provided like this. If we are moving from bridge to the land, then it should be provided as the weight as 1. If from land to the bridge, the weight should be provided as 0. Now, for constructing the spanning tree, various measures can be taken. Either it can be the bandwidth, or it can be the number of hops, or it can be the data rate, etc. Okay. So now, if we consider the number of hops as a metric to construct the tree, what we are considering, that from reaching from B1 to land 1, it takes the cost as 1. From the land to the bridge, the cost is 0. You can see that here it's from land to bridge when it is moving, so the cost is 0. From land to bridge, this is 0. From bridge to land, it is 1, and so on. So you can see that this is how it would be constructed. Now it has to, by looking at this, it has to construct a spanning tree, which is something like this. So you can see that B1 is my root. Okay. And from bridge to land, the cost is 1. So here to here, it would be 1. Now from here to here, so you can see that this is 1. From and land 1 to B2, it is 0. So 1 plus 0 is 1. So you can see that from bridge B1 to B2, again this is 1. Okay. Now from B1 to land 3, you can see that B1 to land 3. Okay. So this is 1 plus 0 plus 1. So this is land 3. So 1 plus 0 plus 1 is 2. So here you can see 2. In case if this metric, if there is a tie here, say suppose if I am going through this, or if I am going through this, if I'm going through this, if it is having the same cost, then the system administrator will decide which of them, it is its job to break the tie. Okay, it can select any one of them. So assume that we have selected here from here to here. Okay, 1 plus 0 plus 1, that is 2, and so on. Similarly, from here to here, it is 1. 1 plus 0 is 1 here again. From here to here, it is 1 plus 0 plus 1. So that is 2 here. 1 plus 0 plus 1 plus 0. So it is here 2, and so on. So all these paths are considered, whereas this is removed, this is removed, and this is removed. Okay, so you can see that this would be my spanning tree now. Hope this is clear, everyone. Hello. Going further, let's see parenthesis. So you can see that this, if I construct it back, if I show this, so you can see the edge from B3 to land 3, B3 to land 3. So this B3 to land 3 is which one? B3, and this is land 3. So this would be removed. Okay. Similarly, the edge from land 4 to B5. So land 4 to B5, that is also removed, and so on. This is how it is. And these edges are now known as the blocking edges. So these would not be considered while it has to forward the frame from one land to the other land. Okay, they have to follow this a particular path. In case if one of the connector, or if one of the connection has failed, in that case it can use the alternate. It can start the blocked edges would be now activated, and that would be used. Hope this is clear, everyone. So you here also you can see. So these are the lands, and these are the A, B, C, D, E, F, G, H, I, J. All these are the bridges. Okay, and by applying this spanning tree algorithm, some of the bridges would be uh, these code would be removed or they cannot be used. That is not part of the spanning tree. Okay. Hope everyone is clear with these things. If you have any doubts, let me know. Yes, that's what I said. The in this we have discussed. So the same frame is circulating again and again. Okay, to remove this loop, some of this bridge is used as a standby. Okay, in case if this fails, the other can become active. It would be active. Is this thing clear? Okay. If you have any doubts, let me know. Now, we'll see at different layers, we are having different devices to connect different networks. Okay. So we can see that here at the physical layer, we are having, see at different layers, we are having different devices. For example, at the physical layer, we are having repeaters or hubs. At the data link layer, we are having bridge or switch. At the network layer, we are having the routers. Then at the transport and application layer, we are having their corresponding gateways, transport gateway as well as the application gateway. Okay, we'll see what are the differences of all these connectors. You can say connectors because it is connecting different networks or different while communicating with different types of networks. How it would be helpful, that we'll see. Now, at the most lowest level, which is at the physical layer, the devices which are used are repeaters as well as the hub. Okay, what do you mean by repeater? I think in the last lecture we have discussed. And what is the function of the physical layer, first of all? All of you remember in order, pre-order, and post-order. Hello. What is the function of the repeater? Amplify the signal. Very good. Okay. So usually the function of the physical layer is to just transmit the frame as it is getting info. It doesn't know which part is the header or which part is a checksum or which part is the data. It doesn't know anything about it. Okay, just as the data comes, it has the data comes, it has to just place that data onto the transmission media. Okay, and as we know that if we are using different types of transmission media, after some distance, the energy or the signal level would be reduced or it would be decayed. Okay, so so in between, some repeaters would be used, which would amplify those signals. Okay, if it is 0 and 1. Okay, so and if 1 corresponds to 5 volt, and as it moves to this to a longer distance, this 5 volt would now be reduced to 2 volt. Okay, so it is a function of the repeater to amplify this signal, and again to restore its amplitude back up to for the 5 volt and forward and continue transmission. Okay, that is the function of the repeater. It just amplifies the signal while it gets it, in case if the signal is deteriorated. Now, whereas in case of hub, okay, so you can see that this is the hub. So whenever some data comes at one of the, you can see here, the hub means what? All these hosts are connected through this central station, which is known as a hub. Okay, and the hub has an number of input lines. Like these are the number of input lines. Okay, and all of them are joined electrically. Electrically, they are joined together. Okay. So frame which is coming from any of these lines, they are sent out on all the other lines. So it is sent to here, 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 everywhere it would send. Okay, so that is the function of the hub, and it is in case if two frames arrive at the same time, then there would be a collision. Okay, so this is how the hub would work, and that is also at the physical layer. The next device which are at the data link layer is nothing but the bridge, or which is known as bridge as well as switch. Okay, so we have also discussed about the bridges and how the bridge would work. Right? So you can see that there are different lines and they are interconnected through this device which is known as a bridge. Now, this bridge is usually what it will do, based upon the destination address, either it forwards the packet frame to the other LAN, or it would discard that particular frame. In case if the destination address is on the same LAN, then it just discards the frame. Whereas if the destination address is on some other LAN, it will forward it based upon the destination where it is present. Okay, so the other problem with the bridge, we have also seen that every bridge would have their card. So suppose this is my Ethernet card, which is also known as a line card, and this is known as a token. Say suppose this is a token ring card. In case if I am having an Ethernet card, then I cannot send a frame which is of token, because it does not know anything about the frame format of the token. Okay, so it has a different line cards based upon the type of networks. And every bridge will have its own collision domain. Okay, so for this LAN, the collision domain would be this much. For this LAN, the collision domain is this one. Okay, so using this bridge, we are separating the collision domain. Whereas here we are having one more device which is at the data link layer, is the switch. Okay, so in case of switch, in case of bridge, what we are having, it is connected to different LANs, whereas here it is connecting all these hosts. Okay, individually it is connected. Now, when a frame comes to the switch here, by looking at the destination address, okay, so say suppose if it is meant for the host B, then it would specifically forward that particular frame to the host B. Are you getting me? Okay, it would forward that particular frame to a particular host, whereas here what it will do, the bridge would just broadcast that particular frame over the network, whereas this would individually provide it to the different host connected to this switch. And this, so suppose if in case of bridge, if there are a number of frames which are coming here at a particular port, and if the buffer is already full, then it may discard those particular frames. Okay, whereas here, because we are having individual lines, and every line may have certain buffer, so there is a very less possibility that the frames would be lost. Okay, but in case if the rate of data transmission is more than that of the data reception, say suppose A is having very high bandwidth, and if it is transmitting at very high rate, then the receiver can receive it. In that case, only in that case, some of the frames might be lost. Okay, so this is the difference between bridge as well as a switch, and both of them would be working at the data link layer. Okay, and because both of them are using the destination address, that is the MAC address. What for the Ethernet, what is the size of the address, MAC address? What is the size of the address in case of Ethernet? Yes, very good. It is of 48 bits. So the MAC address would be of 48 bits, and both the switch as well as the bridge would check this 48-bit address. Okay. Now, as I said, in case of switch, as and when if the data rate of if the transmission data rate is high, then it might be possible that some of the frames would be lost. So this problem can be overcome up to some extent by as soon as it is getting this frame, and when it gets this destination at 48-bit destination address, and when it comes to know that it is the destination address is B, at the same time, while it is getting this frame, at the same time it is forwarding that to the destination B. Are you getting this? It is not like store and forward. In the bridge, we can do first it will get entire frame, and then it can forward to the specific destination based upon the destination address. Whereas here it would not do so. What it will do, as and when the frame is coming and when it finds the destination address, because in the frame format, the source address, destination address would come first. So as and when it finds the destination address, and before the data is still receiving, at the same time it will start forwarding that particular frame to the particular host whose destination is provided into this frame. Is this thing clear, everyone? And this is also known as a cut-through switches. This type of switches is known as a cut-through switches. Hope everyone is clear with this cut-through switches.
2, 5, 6, and 12, 14, and 15.
Hello.
Become the right. Then same thing is applied over here. And if you
understood or not?
That's for the straightforward way.
How about this? Are you all with me?
You can construct the full binary.
Okay.
So again the same thing is there.
Okay, let me.
So in fourth order, basically,
Say A is transmitting the data frame at very high rate, say 10 Mbps. This is the data rate of sending the frame from A to the switch. And when the frame is sent, the frame would have the source address as well as destination address, which is of 48 bits. Now, usually what it will do, it would first it would get the frame entirely, okay, and it would put it into the, as the frame is arriving at the switch, it would just buffer it, okay, and based upon the destination address, it would forward it further. Okay, so suppose if the destination is B, then it would forward it to B. Is this thing clear? But in case if the data rate is too high, it would start pouring the number of frames to this, and the buffer would be full. Okay, so in that case, it may not use the store and forward type. What it will do, as soon as the frame it is receiving, because it is a serial type of data communication, isn't it? So bit by bit, it is receiving the frame, and while it is receiving, and when it receives this 48-bit destination address, it would come to know that which of these hosts it has to forward. Say suppose C is my host to which the frame has to be forwarded. A has to be A is source and C is the destination. And when the destination address is received by this switch, it would come to know that it is for the host C, and as it is receiving this frame, meanwhile it is something like it is connecting from here to here. Is this thing clear?
it means we have to see the root first. When we are taking it, left pointer is not null. It's not null. We are recurrently calling this with.
It is something like it is connecting A to C. By looking at this destination, it would come to know that it is for the host C, and directly it would connect it like this. So this type of switch is known as a cut-through switch. So all the data would not be stored here. Instead, it would be just forwarded to the host C. Hope this is clear, everyone. Now at least. Hello.
Similarly, recursive algorithm from fourth order, right? And then
Okay. So this is about the bridge as well as switch. The next device which is used at still the higher layer. It is nothing but the router. So you can see that at this TCP transport layer, it provides this TCP header with this user data. Then comes the network layer. It would provide the IP address, etc. That is the packet header, which is at the network layer. Then comes the data link layer, and it provides its own header, that is a frame header, which contains the MAC address of source address as well as the destination address. Whereas here, what are the address here? These are the IP addresses which is provided. Are you getting this? Okay, and here it would be the checksum. Okay, so the frame header as well as the CRC is provided at the data link layer. The packet header is provided at the network layer. The TCP header is provided at the transport layer, and then comes the user data. Hope this is clear. This is how the entire data with the headers are provided at each of the layer. Okay. Now comes the network layer, which contains the router. The router is a device which would be used and it the function of the router is to route the packet because it doesn't know from where it is receiving the frame, from where it is sending the frame. Nothing is known at the network layer, and there would be certain device which so CPU would be there. Or whenever a packet comes to this CPU, so it would check the IP address, and here it maintains a algorithm. The routing algorithm would be maintained, and based upon that, it would decide the route and it would forward that packet to the further nodes, isn't it? So this is how the network layer would work, and we have already discussed how the routers, etc., would be working while we were discussing about the network layer. Then comes the other two gateways, which is working at the transport layer as well as the application layer. The transport layer gateway, the function of this gateway is to change the format of the data based upon the type of network which is used. Okay, based upon the different transport layer protocols which is used. Say suppose if it is using TCP and some other host to which the data has to be transmitted, it is using some ATM type of network. In that case, it is a function of the transport layer gateway to convert this packet of this TCP, which is in the format of the TCP, to the format of the ATM. Are you getting this? So if we are using different protocols, as in the earlier case also, in the bridge also, it would convert from 802.x to 802.5. Isn't it? Similarly, if you are using at transport layer, if we are using different types of protocols, in that case, it has to convert based upon the destination type of protocol. It has it is a function of the gateway to change the type of the packet based upon the destination. Okay, so this is about the transport gateway. Then similarly, the application gateway. Now, as we know that we are having different types of messages which has to be sent from one host to the other host. For example, an email gateway, which and if it has to convert itself to the SMS gateway. Say suppose if it is using the mobile, it is using the host B is using some mobile devices, then it accordingly it has to change the format from email gateway to its corresponding SMS gateway, or the format in by which through which the host B can receive those emails also. Okay, so all these changes which has to be made is this at the application layer, and the changes which is to be done, it has to be done by the gateway which is known as a application gateway. Is it clear, everyone? Okay, so these are the various devices which are used at the different layers, and at each layer this is how it would work. Okay, At the TCP layer, its corresponding TCP header would be added. At the network layer, the header would be added. At the data link layer, it would add the frame header as well as the checksum. At the physical layer, what it will do?
Now assuming there is no left.
Are there any headers which has to be added at the physical layer?
There are no left. Will it be null? Yes or no?
No, because it has to just the raw data, the raw bits which of the frame has to be transmitted. It doesn't know anything about what is the header, what is the checksum, what is the part of the addresses, etc. Isn't it? So this is about repeaters, hubs, bridges, switches, etc. Any doubts?
There I get fine. So my end.
So this completes your MAC layer. Any doubts if you are having?
Can I do this?
And from my part, it is finished. If you have any doubts, let me know.
Let me explain you just an example. This is a simple tree.
Hello.
Tree
Any doubts from any of the part?
right? Imagine there are no such errors available, right? And
How about others?
they can make a representation of A, B, C. Now, if I want to write
Okay, then we'll stop here.
down
If you have any doubts, you can ask. Still 2 more minutes are there. 3 more minutes are there,
that
so that it will be clear to you all how.
he has anything in left and right? He does not have anything. So for B, what will be its left pointer? What will be its left pointer for D?
Okay, then if you don't have any doubt, I'll stop.